This video will talk about the third of the three types of structural isomers found in organic chemistry. Remember, there are 5 total types of isomers in organic chemistry. These ones are going to be your structural isomers, and we're going to look specifically at the functional isomers in this video. If you haven't already watched them, please make sure that you do watch the skeletal isomers and the positional isomers to see how they are different from the functional isomers. So in this video, we're going to talk about isomers that are structural isomers. That means they're bonded together in some different way, and they are functional isomers. Functional isomers are ones that have different functional groups present. Functional isomers have the same molecular formula, but will differ in the type of functional group they have, which means that the class of compound will differ. Let's start with letter A, which has the molecular formula C4H6. First, we need to find those functional groups. So in the first one, we see there are 2 double bonds, and in the second one, there is just a triple bond. Since these have the same molecular formula, but 2 different functional groups, these will be functional isomers. Let's do a little practice with naming. So we have the first one, the classification, when there's a double bond present, is alkene. And for naming this, the ending will be -ene. There's 2 of them, so we're actually going to put in diene because there's 2 of them. We have 4 carbons in the chain, so that would be butadiene. But again, that has that error of sound. The TD should not be next to each other, so we're going to add an A back in, and this becomes butadiene. Now we need to put what number they're on. And so the first one is on number 1, and the second one's on 3, so we put 1, 3 dash butadiene. And the second one is an alkyne. So alkynes endeth YNE, and in this case we have 4 carbons in the main chain, so it's a butyne. The triple bond is on carbon number 2, so this is 2-butyne. For letter B, we have C4H10O. The molecular formula is the same, so these could be isomers. And we'll just look at them. We find the first one has this OH. The second one has the oxygen in the middle of 2 carbons. When we have a OH, that tells us which class of compound do we have. Hopefully you got alcohol. And for the second one, we see an R on both sides of the oxygen, no C double bond O's, and that one should be a ether. And so let's go ahead and name them for practice. If it's an alcohol, it ends with OL. We put an AN in front of it to say that all of the other bonds are single bonded. 4 carbons in the main chain, so it's a butanol. And then we're just going to say what number it's on, and this is going to be on number 2. We're going to have to count backwards to give the lowest number, so 2-butanol. And the other one is an ether, so we're going to have ether name could be the main chain. Whichever one's longer will be the main chain. In this case, they're both 2 carbons long, so it's going to be an ethane, and then the attached group is an oxy, so we're going to put oxy in front of that. And then the attachment that's on the oxygen is just 2 carbons long, so it's another eth, and so we end up with ethoxyethane. And then if we were to put the number in, we would have said it's on carbon number 1, but again, we don't put that number in because it's not required when there's only one place it can be, and it can only be on carbon 1 of the 2 carbon chain. But recall that we're looking to see that this is a functional isomer. One of them's an alcohol, the other one's an ether. You do not have to go through naming to discover that it's a functional isomer. Now let's look at letter C with the molecular formula C4H8O. We know that these 2 have the possibility of being isomers, and we're going to find out which kind. And the first thing we're going to do is look for those functional groups. Here we have a C double bond O, and over here we have a C double bond O. Seems like they could be the same. But the first one is on the very end, so that we have a hydrogen attached to the carbon that has a C double bond O. And that makes this one a aldehyde. And on the other one, number 2, we have 2 carbons on each side of the carbon double bond O. On that carbon, there's a carbon on both sides. That means that it is a ketone. So these are different functional classes. One's an aldehyde, one's a ketone, and that tells us that we have a functional isomerism. We'll do a little quick review for naming. The first one is an aldehyde, so it ends with Al. An goes in front of that so that we can show that all of the other bonds are single. Then we look at how long the chain is. It's got 4 carbons, so it's but-and-al. No number goes on this one because aldehydes are always at number 1. For the second one, we see it's a ketone. The ending is -one. We put an an in front of that to say that all of the other bonds are single bonded, so we have -anone. And then we look at how long the carbon chain is. There are 4 carbons in the carbon chain, so this is a but-anone. And if we were to put a number on it, it would be on number 2. But in this case, we are not supposed to put the number, because if we put it on number 1, it would be an aldehyde. If we put it on one of the 2 in the middle, both of those are 2-butanone, and then again if I put it on the end, that's like the first one, and it becomes an aldehyde again. So there's only one form that can be butanone, and it has to have it on one of those 2 center carbons. Now let's finish this up with letter D. D has the molecular formula C4H8O2, and these two both have that molecular formula, so we're going to see if they're the same or not. We look at both of them and we see that there's 2 oxygens on the same carbon for each of them. So we have a C double bond O OH and a C double bond O OR. When we have a C double bond O OH, that is which class of compound? Hopefully you got carboxylic acid. And when we have a C double bond O O with an R group on that oxygen, now you have which class of compound? And hopefully you got ester there. So let's go ahead and practice their naming. For the first one, we have a C double bond O OH. That's a carboxylic acid, so we're going to put oic acid at the end of its name. We put the AN in front of that, and then we look at to see how long the main chain is. There are 4 carbons in the main chain, so this is butanoic acid, and you should not be putting a number in here because the acids do not get numbers. And our last one, we have a C double bond O OR, and hopefully you were able to classify that as a ester. For the esters, for naming, it ends with O8, and then in front of that we're going to put AN because we know that everything else is single bonded in the chain. So we have an anoate, and now in front of that we're going to put how many carbons are in the main chain. This one isn't a great example, but to remind you, the one that's going to be the main chain, whether it's shorter or longer, is irrelevant. It only matters that the one that is the one with the C double bond O, that carbon must be part of the main chain. So we know that in this case we have 2 carbons, that's an ethanoate, and then we have the attached group, which is also an ethyl group, so we have ethyl ethanoate.